Welcome back, ladies and gentlemen. In this video, we're talking about the broad concept of energy, a super important topic. Really was roughly 150 years ago, 160 years ago, first kind of recognized for what it is, because it's kind of an abstract thing. These ideas, the word has been around a long time, but the ideas in physics have been developed only for the past 160 years or so. Now, this word energy, you've heard it many times. We use it in everyday conversation about things like energy generation, electrical energy kind of stuff, powering your homes, charging your cell phones, all kinds of good stuff. But to a physicist, energy basically, we can use a definition like this. Now, the definition is, you'll see, may not feel helpful at first, but we're going to use the definition and check it against what we might observe around us. So the definition of energy, the ability of an object to change something about itself or the world around it. So can that object change something about itself? Or can that object change something about the world around it? And that's how we will judge whether an object has some energy. Energy comes in many forms. And this list that I've got here is not necessarily an exclusive list that contains everything there is to know. But it's got some really common things that you'll see often. For example, the energy of motion. We would call that in physics kinetic energy. The energy of an object in a gravitational field. And we would call that gravitational potential energy. Those are two very important terms and ideas in physics. When you combine them, they kind of fall into this category called mechanical energy, or I'll just use the term energy in general. And we're going to dive into some detail in that later on. Also, other types, you would have elastic energy, for example, the energy that would be in a rubber band that you stretch. Chemical energy, you eat food and you get energy from the food. That is basically energy in the chemical bonds in that food. And your body's really good at breaking down those bonds and deriving the energy from it. Thermal energy, heat from various sources, from the sun, from whatever fireplace you got, anything like that. And electrical energy. We will actually study electrical energy later on in the semester. But these are different kinds of energy. Energy comes in many kinds. And the neat thing about energy is, I know you've heard this before, that energy cannot be created or destroyed. Well, okay, that's true in a fundamental sense. But you can produce energy. The thing is, you have to get energy from somewhere else. And really what you're doing is you're transforming it. For example, water going over a water wheel, if you can picture that in your mind, old technology. But basically what that's doing is using the gravitational potential energy of the water and letting the water fall, and it's giving up that gravitational potential energy. As it gives up that type of energy, well, as it falls, it turns the water wheel, and therefore you've got motion, and therefore you're gaining kinetic energy. You're trading one kind for another. And that is actually all that ever happens. One kind is going to be traded for another, and there are losses along the way, and things aren't exactly as efficient as we want them to be. But that's the idea about energy. And we're going to focus, as I said, on kinetic energy and gravitational potential energy. Let's get to those real quick. So check this out. We've got energy as a quantity we can measure, and we can do some calculations with it. And so there's going to be some units of energy that we deal with as students of physics. It's called the joule, Joule, and the symbol would be a capital J. Now, you don't have to write these things down, but some interesting facts, a little bit of trivia, that might help you relate to what a joule actually is. So 1 joule of energy is the energy needed to apply a force of 1 Newton to an object as it moves 1 meter. And if you happen to remember about how big 1 Newton is, well, it's roughly equivalent to a quarter pound. So it's a very light kind of force, very small force. And moving an object 1 meter, it's not that far. So 1 joule of energy is not that much energy. In fact, this might give you an even better idea of how small a joule is. A typical apple might have 100 calories in it. Calories are actually a measurement of energy. Now, if you've been through chemistry, you know there's 2 kinds of calories. Maybe they teach this in biology as well. There's something called the calorie and something called the kilocalorie, or the kcal sometimes. The calories we eat are the kilocalorie kind of calories. A lot of K sounds are alliteration. Wow. Anyway, that apple that has 100 calories in it is going to contain over 400,000 joules of energy. So a single joule is not a lot of energy. It's actually a pretty small amount of energy. Just to give you some idea. Now, back to the idea of mechanical energy and kinetic and potential energy. So mechanical energy is kind of a group category, and it includes kinetic energy of an object plus the potential energy of the object. If you want an equation, it would look like this. Just a capital E for mechanical energy. It equals kinetic energy plus potential energy, and we're usually going to be dealing with, in fact, I think we're always going to be dealing with the gravitational potential energy, so that's why you got a little g here. There are other kinds of potential energy, but we're not going to dive into those right now. So the equations, so we're dealing with this new ideas, these new mathematical things here. Kinetic energy has its own little formula. Kinetic energy of an object is the energy of the motion, so you would expect velocity to be in the equation. 1/2 times the mass of the object times the velocity of the object squared. And that tells you how much kinetic energy that it has. Potential energy, that's gravitational potential energy. Well, what you would do, since it's the energy of the object inside a gravitational field, you basically need the mass of the object multiplied by the acceleration due to gravity multiplied by the height of the object. And the height of the object is just measured from some level that you decide you're going to measure from. You get to pick where 0 is, and you're going to measure from 0 and say, well, it's this high or it's that high. And so we'll work on that. In fact, both of these. I'm not going to show you examples here in this video, but we will look at these two things in detail in class and get some practice using them. But let me do one last thing in this video to help you kind of grasp what's going on perhaps and see some insightful stuff. So the units are joules. So kinetic energy is measured in joules, yes? Well, how does a joule equal what you get out of this? So what does this side equal? What are the units on this side? Well, 1/2 doesn't have any units to it. Mass. In physics, we measure mass in kilograms. And velocity has units of meter per second. And so we've got meter per second, but that's squared. So I'm going to have this squared. All right, fair enough. So what does that really kind of boil down to? Well, a joule is equal to, and I've got kilograms and meters squared, and I'm dividing by seconds squared. So a joule is equal to a kilogram meter squared per second squared. That's how you would say that. Finally, over here, so potential energy, gravitational potential energy. Well, it's also measured in joules. All kinds of energy can be measured in joules. Well, what's going on over here? It seems like if it's going to be equal, then this side has to equal joules also. So this side has to give us the same units as this side does. It should anyway. Let's find out. So mass is going to be measured in kilograms. What are the units of acceleration due to gravity? Well, it's an acceleration, so that's meters per second squared. And the units of height, well, we'll measure that in meters. So what do we have going on? Kilograms times meters is meters squared, and we're dividing by seconds squared. It matches. So the units all add up together, or they all match. It all works out. So anyway, you do not have to memorize that it is a kilogram meter squared per second squared. That's not an important thing to memorize. However, you may. What you do want to remember is that any kind of energy will be measured in joules. Doesn't matter if it's potential energy, kinetic energy, or any other kind, like any kind here, we could measure all of these in joules. And we will work with kinetic energy, we will work with potential energy, we will work with total mechanical energy as well. But that's coming up later. Thanks for watching. I'll catch you next time.